X265 and X264. So as most of you are probably aware, X265 and X264 today are the most popular open source codecs which are used when one wants to encode video with HEVC. X265 is used for HEVC and X264 is used for AVC. And these two codecs are widely used not just for offline encoding for OTT streaming, but also integrated into several live encoding platforms, which things like Zoom and several other platforms actually also use software encoding, especially when they want to focus on good quality. Now, the main limitation that these codecs suffer from when one tries to use them live is that because of their existing integrations with either their own app or into FFmpeg, the encoders have to be configured with the most conservative settings to ensure that it can sustain live speeds, for the target resolution and FPS. And in case the content is simpler than in case the content is simpler to encode than the worst case settings, the encoders cannot react dynamically. And so this is a serious limitation because live content is known to be dynamic. In fact, you're expected to see several times when the content becomes simpler, more complex, and you want to be able to dynamically react and adapt to the content. And that makes the quality of your stream even better. So that's exactly what we actually do, right? So in this paper, we present a very simple framework which is built on top of our understanding of both X264, in which we have worked very extensively, and X265, for which we are the authors of X265. And we leverage the existing APIs of X264 and X265 for dynamic reconfiguration. And we monitor the frame rate that the encoders achieve and try to tweak the encode such that live frame rate is always maintained, but in the pockets when we can improve the quality, we actually go ahead and reconfigure the encoder to improve the quality. So this implementation is actually available as part of a premium encoding solution that we offer from Multicoreware. If you're interested further in this technology, of course, you can always write to me, or you can contact us to see if this fits your live streaming needs. That's all I have to say at this point. There's a short clip about the overview, and my full detailed slides are also available from the program for you to look later.
Thank you, Pradeep, for the presentation. And this was paper 1. So for the Slido questions, please label it as paper 1. And now let's move on to the second paper. So it's CADwise, cloud-based adaptive video streaming evaluation framework for the automated testing of media players. And Babak Taraki from Alper Adria Universitat Klagenfurt will be presenting it. Babak, I'll make you presenter right now, just a second. Babak, can you hear me?
Yes, thank you, Agus.
Please go ahead. Yeah.
Should be able to share my screen. Can you see the screen?
Yes, we can see your screen, yes.
All right, great. So I actually prepared the demo session instead of the presentation. So I'm going to, because we don't have much time, I'm going to directly jump into the demo. This is actually a paper that would help us to evaluate how does the media players would adapt to the network fluctuation. So basically it would be run in the AWS cloud, and I'm going to run one demo here. If you can see my screen, this is the command that I would execute to run the test. And once this is entered, executed, you would be able to see the EC2 instances in the AWS cloud gets initiated, and it takes some time to run the softwares on the EC2 instances, and also to make the network interfaces be reachable from our side. But once that is done, some script will be injected, copied to the EC2 instances, as you can see here, and those scripts will get executed as an initializer for each EC2 instance. And if we try to connect with the SSH command to the EC2 instance, we should be able to see we should be able to see the network situation. Okay, it's not done yet. So this usually takes like somewhere around 2 minutes. And once that is done, we should be able to connect to the server here. And from there, we can see the network situation. How does it actually being shaped based on the attributes that we define for the network. Once that is visible, we can check that. But before that, there is something I wanted to share with you as well. This is the network. This is the Bitmove Analytics dashboard. Here, when we have the test running, we should be able to see in real time the various types of metrics. For example, one of the most important one, I guess, is the startup times, and other metrics as well are available here. So this is done. The instances are initialized already, so we should be able to see the network situation here. I will try to run this command, and this is actually showing the ingress and outgress bandwidth for the server that we defined. Plus, on top of this, if you want to take a look at one of the media players that I have here, for example, this is -GES. We can connect with the VNC viewer to the server, and we should be able to see that the player is playing the stream and being automatically tested. And at the same time, this would send the data, for example, the metrics that we want to the Bitmove Analytics dashboard. This is one of the players. If you want to check another one, for example, the Bitmove players, we can pick up the IP from here, paste it here, and connect with a secure password. And then we should be able to see the Bitmove player as well, playing the same stream at the same time. So, okay, luckily we see both of them. Now the test is finished and the EC2 instances being killed by the application, and we should be able to see the results here. As you can see, we run the test for one time only, and this is the startup time for each media player. It's easily to compare. It's easily being compared, and also the average bit rate that you can compare as well. So there are a lot of metrics here. It's possible to also create customized diagrams here as well, but that would take more time. So I just prefer to show you the minimum viable product for this paper. And with that, I would like to conclude this demo and get back to you, Emre.
Thanks, Babak, for the nice demonstration as well. So this was paper 2 for the Slido questions. And now let's move on to paper 3, which is low latency dash, more than just specs, dash IF test tools. And Ece Öztürk from No More Research will be presenting it. Ece, I will make you co-host right away. Ece, can you hear me?
I can. Okay. Can you hear me?
Yes, we can hear you.
Okay.
And we can see you as well.
Yeah. So I'll
Please go ahead.
The screen. Okay, so today I will just present the reference and testing tools that we have within DashIF and how to use them with a case of low latency Dash. DashIF is an industry for DashIF is a forum founded to catalyze the adoption of MPEG Dash, and for this it provides interoperability guidelines and the supporting materials. These include also the reference tools, and everyone is encouraged to visit the website of DeshIF to check what the working groups are and what is being done in detail. All work in DeshIF is supported by testing and reference tools, and these include conformance validator, test assets, and reference player. The conformance validator basically checks the validity of the prepared content according to the specifications. These specifications are Dash-specific, Dash-related specifications. The test assets category includes actually two different assets, two different contents. One of them is the test assets database, which actually is used to host sample conforming MPDs. These are called the test vectors. And the other one is the live source simulator, which provides the live streaming service with desired features generated completely from a VOD content. And lastly, the Dash.js reference player is a reference reference client implementation for playback. And all these tools are publicly available for community use and contribution. And these tools are regularly updated according to the latest standards done to the different Dash-related specifications. And I can from here go on to the demo. So the latest extension that we have done to these tools is the low latency Dash. And for this one, we can start by the live source simulator. This is one of the URLs that the live source simulator will provide as the live service for low latency Dash. And as you can see within the URL, you can provide different configuration parameters, and these specific two configuration parameters define the basic low latency live service. And this generates the output, as you can see, the MPD over here. And you can also notice the low latency features such as the latency, which provides target latency on the client device with the minimum and maximum boundaries. And it also contains the information on the segment availabilities. For example, this availability time complete being set to false signals to the client that these segments are generated in runtime and they can be accessible prior to their completion. And the availability time offset also signals to the client how long ago they can access to these segments prior to their completion. And using this one, I will go on to the demo part that we can actually validate the content. I just need to change the shared screen. Okay, so this is the conformance validator part. And here, all you need to do is to provide the MPD here. You can also enable all different modes. For us, it is the low latency Dash, and we would also like a segment validation. If not checked, it would just perform an MPD level validation according to the low latency Dash. And when you click run, you can see that it starts performing all the validity checks one by one. This might take just a bit more, but as you can see, it provides the logs. For example, this one is for the MPD level checks, and you can see that it passed with minor warnings. And unless this is an error, it's not something that needs to be fixed right away within the content. It's just something that the content provider should know about. And this will go on. So maybe I just move to the player and then go back to that place again. And for the player, we can again just provide the URL over here. And from the options, I will just enable the low latency mode and click on load. This low latency mode will ensure the usage of the low latency parameters defined signal in the MPD, and it will try to adjust its live latency according to the target latency, which was signaled as 4 seconds. And you can see over here that it's something below 3 seconds right now, which is within the boundaries of minimum and maximum latency. So I will stop this because there is the audio coming in. And you can also see here that the conformance software validation has finished. And here we also have passed with the cross-validation checks, which checks the switching between the different representations and adaptation sets type of validation. And these are also passed with the warning. So it means that this content is actually conforming. And yeah, this would be all the demo that I would like to share.
Thanks, Ece. This was a nice
So,
demonstration as well. Thank you. So this was paper 3 for Slido questions for your labeling. So let's move on to paper 4, a cloud-based end-to-end server-side dynamic ad insertion platform for live content. This is from Tankut Akgül, who will be presenting it from Istanbul Technical University. Tankut, just a second. Yeah. So I made you co-host now, so you can unmute yourself and present.
Can you hear me?
Yes, we can hear you. At least
Okay,
I can.
Okay. Hopefully you can see me as well.
Yes, we can.
Okay, good. So let me share my screen quickly. All right. So together with me today are my co-authors, Samet and Alihan from Ednext Mediatek as well. So as you know, dynamic ad insertion is the process of inserting ads into a stream, a video stream, which may be personalized ads based on user preferences. So we are mainly focusing on live TV streams here, digital live TV streams. And when we talk about live TV streams, there are actually two commercial insertion, two target commercial ads we can replace with personalized ads. One is the ads that we display during the regular broadcaster commercial break period. And the second one is something we add on top of this, which we call the personal sweet spot. And these are ads like the mid-roll. This is a single ad that we insert at different points in time in the stream. And this can also be personalized based on user preferences. And what we have seen is with the PSS ads, we can achieve 95% viewability and 97% completion rates. So we believe this offers new monetization opportunities to broadcasters, especially in the live TV ecosystem. So if you look at the architecture, there are actually two parts in the system. One is the video plane, which provides ABR streaming with dynamic ad insertion support on server side. And we have the ad management plane, which is responsible for serving the ads, collecting analytics information, as well as providing the broadcasters and the advertisement agencies with the interfaces to manage their inventories, campaigns, budgets, etc. So everything here except the client, the player, as well as the encoder runs in the cloud. And there's no single point of failure in our system. So especially the stitcher, which is responsible for generating the dash and HLS manifest, scales with respect to the incoming request from the clients. And it maintains a separate session with every client, basically. So every client can potentially see a different set of advertisements while watching the same content. And one nice feature of the encoder cluster we have is the real-time ad detection. So we can use SCT35, this traditional way of detecting ad Q in, Q outs. But we also do classical image processing as well as deep learning methods, based methods for detecting spatial visual markers, which are actually mandatory in Turkey and probably in some other countries as well. So these are displayed while entering or exiting the commercial break periods. So we can detect these and start stitching our ads dynamically. We have a player which is VAST compliant. It integrates nicely with third-party measurement companies using their tracking codes. It's an interactive player and also supports near real-time logging or client statistics to the backend servers. And then we collect this information and then display some visualizations in a local server, which runs on Elastic Search, ELK service. And then we not only collect information from the clients, but also all the server components in the system. And we can set up automated actions, alarms if something goes wrong. So it's very helpful for viewing the performance of the system. So I'll show a quick demo of ad insertion. So you can see here on the left-hand side, the personalized stream that we generate. On the right-hand side, the original stream from the broadcaster. I'll skip a little bit to the first commercial break. So it will start soon. And yeah, you can see the marker here. We detect that and we display it for a few seconds because we have to based on the regulations. But then after some time, we start inserting our personalized ads. While on the right-hand side, you can see the original ads are playing. And we can make the ads clickable. You can see the user clicks the ad and then it directs the user to the campaign web page. And then when we return from the stream, from the commercial break, somewhere here, I guess, yeah. We seamlessly go back to the original content from the broadcaster. You can see there's a delay with respect to the original stream here, and that's because the duration of the ads we insert doesn't necessarily match with the duration of the original ads. So we may fall behind the live stream, but we compensate for that in the next commercial break period, basically, by reducing its duration in the next commercial break period. So we have a few more demos, especially the first one I list here is a live stream. It's a production stream, which we deployed with one of the major TV broadcasters in Turkey. So in conclusion, we have a fully scalable end-to-end dynamic ad insertion and management platform, which supports both Dash and HLS. It's fully compliant with IAB standards and fully transparent in terms of the measurement, tracking, ad tracking. And on top of all, we have deployed this with 4 major TV broadcasters in Turkey. So it's deployed and proven on the field with thousands of concurrent users. So thank you very much.
Thank you, Tankut. This was paper 4 for the Slido questions. In the meantime, when you have the time, especially for the presenters, please also check the Slido questions and get ready, and you can also reply there without waiting. So let's move on. Paper 5 is towards HTTP adaptive streaming, implementations and challenges, and Reza Shokri Kalan from Digiturk will be presenting it. Reza, just a second. I now made you co-host, so you can unmute yourself. Reza.
Do you hear me?
Yes, we can hear you.
Let me share my screen, please.
Yes, we can see you as well. Reza, we are seeing now the correct one. Yes. Okay.
Hello, everyone. My name is Reza Shokri. I'm from Digiturk company. In this paper, we aim to address some of essential challenges during transforming from legacy streaming technology into HTTP adaptive streaming technology in Digiturk OTT platform. With increasing popularity of the internet and smart device, demand for live streaming also increased. RTMP has been de facto protocol for a decade. However, it has drawback in terms of firewall transparency, scalability, and deployment dependency. Firewall-friendly nature of the HTTP adaptive streaming technology has packets pass easily through routers and firewalls. Also, as technology allows us to use traditional HTTP web server for content distribution, hence provide rapid adaptation and very scalable system. This figure shows our system architecture. As shown, we introduced a CDN agnostic origin system that can work with multiple CDN. According to our architecture, encoder performs ABR encoding and push string into origin publishing point. Origin system, which contains 2 modules, just-in-time packaging and origin shell, is responsible for signaling live feed into different clients. CDN are integrated to accelerate by caching stream in edge servers. As a consequence, the REST request is forwarded to origin server. In addition, compressing manual file increases delivery performance. Wide variety of end-user device and DRM requirement cause to stream multiple copies of the same content. To avoid this, we can benefit of CMAP or common encryption. However, client adaptation takes time. Just-in-time packaging simply generate manifest and segment based on the requested and provide dynamic adaptation to future payload. It's also decreased ingest bandwidth and reduced storage cost because it's just keeping one copy of the in storage. Origin shield is a caching layer between origin and CDN with short TTL for manifest and segment. The ideal origin shield should be designed to retrieve content from origin server only once and return the content from its cache. Actually, no need for just-in-time packaging for successive requests, which is more costly. Origin resource utilization is heavily dependent on the number of requests. Request frequency is for a single channel are calculated by considering number of radio representation, segment length in second, number of layout format, for example, HLS, dash, MMS, and also video and audio track multiplex together or not. Compare it with legacy streaming technology or implemented adaptive streaming technology bring advantage in terms of performance and management, especially during the peak time, for example, during the sport events. In this figure, we illustrate our system scalability during the football match. As you see, as shown during the peak time, edge bandwidth rapidly increases, while migress and origin load remain almost the same. It is clear with starting the game traffic at edge point increase. However, origin server work at the same load. It is important to remind that proposed system can scale further by utilizing multiple CDN. As a conclusion, compared with legacy streaming technology, proposed system provide system scalability, especially during peak time, flexible system management and integration, and also system adaptation. For example, recently, global network traffic rise up enormously in lockdown time due to COVID-19, while more people stay at home and work. To address this problem, different solutions are available. For example, use better compression, such as using better codec, such as HEVC or VP9, or using advanced encoding technologies such as content-aware encoding. However, all these tasks, all this take time to deploy. Another solution could be reduced bandwidth requirement or profile filtering, which is adopted by many major OTT service providers. In this solution, profile filtering simply discard high bitrate. Thank you.
Thank you, Reza. And this was paper 5 for the Slido questions. Now let's move on. Paper 6 is HTTP adaptive streaming over multiple network interfaces, and Sarp Öztürk from Özyeğin University is going to present. Okay, Sarp, I made you co-host now. You should be able to unmute yourself.
Okay, can you hear me?
Yes.
All right. Wait a second, please. Can you see my screen?
Yes, now we can see it.
Okay. Hello, everybody. I'm Sarp Öztürk, and I'm from Özyeğin University. So I want to start with our motivation. In the current situation, the people in rural areas or even in the big cities are experiencing a lack of reliable network service or slow connection in DSL. And when they want to watch streams, they get high latency, lower bitrate, and also delays. And all of these cause poor user experience. And as a result of these poor user experiences, clients give up using these apps and services. And this situation is not preferred by the service providers or the content creators. So getting a secondary connection might help in the browsing scenario. Actually, this is an existing technology, and it's also known as link aggregation and broadband bonding. And when we talk about streaming, this technology is not the best fitting approach, since we want to apply the smartest and adaptive solution. And clients with this technology get poor user experiences while they're watching streams. So we came up with a client design which uses multiple connections in streaming sessions. The goal is to enhance user experience in streaming and using multiple connections simultaneously. So we have a client, a gateway, and the media source. As we mentioned, our solution focuses on the gateway part, and it is isolated from the client side. It is important to notice that the gateway has two external networks, and one of them is slow DSL, and the other one is on LTE connection, which is faster compared to the other. Well, of course, LTE is faster than DSL connection, but what we aim here is to minimize the waste of LTE connection quota and improve streaming experience compared to the session with a single slow connection. And for this purpose, the gateway is designed as it learns the states of each network and keeps the states of them for later uses. And it actively measures the bandwidth of each network by sending head requests to source at the beginning. And client use HTTP adaptive streaming in 3 steps. First, client sends a request for media segments over the gateway. The gateway parses this request. It assigns workloads to each network according to their bandwidths or the range chosen by the client. The gateway splits the requests by using byte range among available networks. If there is only a single network, then it continues to run like a regular gateway. And after making byte range requests, gateway merges the sub responses coming from the source. And finally, the response is sent back to the client's device. And while our approach is transparent to the streaming applications and it is adaptive and cost-aware load distribution, but it's important to notice that our approach is most useful when networks are similar. If there's a huge gap between the network speeds, then the approach will not likely to be succeed. So let me show you a quick demonstration of our project. It will be a pre-recorded session. This demo consists of 2 sessions. The first one you're watching right now is the gateway uses only 1 connection, so it's not taking advantage of multiple networks. So as the responses are come, you can see on the left side, we have a log file, and it consists of logs of regarding the information to the progress. And there is no splitting the request into distinct networks. And it's a case which we are not interested in, but I wanted to show anyway. So I will skip to the part where the gateway uses multiple connections. So in this session, the gateway uses 2 connections. It's the same source, and as the responses are coming, you can see that, you can see that 2 networks are available, and they send head requests, and the gateway measures the bandwidth according to it, and they send byte range requests to the source, and their workload are different. So as an accepted result, our approach is shorter, takes so much short time compared to the one with single connection. So that was it. Thanks for listening.
Thank you, Sarp, for the demonstration. So this was paper 6 for the Slido questions. And let's move on to paper 7. Metadata-based user interface designed for enhanced content access and viewing. So Alper Derya from Turkcell will be presenting it. Alper, I just made you co-host, so you should be able to unmute yourself.
Okay, can you hear me?
Yes, we can hear you very well.
Thank you. I will share my screen right now. Yes. Okay. Okay.
And we can see your screen. Yeah.
Okay. Okay. Thank you. Hello, everyone. Our project is about providing a new designed new user interface to show the users the important video marker points. And actually, as you know, a lot of contents are available in the internet right now, and we just think about maybe we can motivate the users find their needs on the seek bar. And then I want to show you three type of usage of our project. And first one is just showing the important markers of the content, just putting small colorful marker on the seeking bar. And I refresh the page, and here is the video player. Actually, there are four colorful markers on the seek bar. If you want to go to one of them, it's enough to click on the markers. And this is the first case I want to show you. Another one is I want to change it from my code right now, and actually it's dynamic, and so I will change this. And yes, another use case is coloring the seeking bar and making the color as gradient, as you see. And actually, it represents a duration instead of a constant point. Think about some of the users watch important part of the video. For example, you can think that the green part is important one and most viewed part, and maybe red one is latest part. This way is used to motivate users to find the important part of the video. And the last usage of the project, putting some useful and meaningful icon on the seeking bar. I'm just changing my variable in the code right now. Just refreshing the page. Yes, as you see, we can put also some icons on the seeking part to show users important part of the video. For example, you are watching the football match summary, and actually you don't have time. You don't have 10 minutes to watch it, and maybe you can use as navigation the markers when you click the goal icon, and you can start to see the goal moment. And of course, you can use another markers. Actually, I want to talk about a little bit the project by showing the code. But I think I need to change my screen. Just a second. Okay, here we are. Can you see the Eclipse right now?
Yes, we can.
Okay. Actually, it's a small lightweight code, and we add -js some libraries, -all-debug.js and control-bar.js, and we create a demo page -js.html, and here is the code we wrote for the show the video on the page. And another small part is the JavaScript page, JavaScript code. And actually we have modes, and just modifying the div content, adding some styling on the div part. And as you see, here is another part of the code, just taking important marker points from database, but it's not mandatory to use database. Maybe you can use Ajax service to get markers. The project, actually the application has in-memory DB, and I can show you here is the some data. For example, you can see the data and duration, start point, and then it's about the icons names. Of course, we store our icons on the projects and then use these icons to show on the seek bar to navigate the users. That's all I want to say. Thank you for listening.
Thank you, Alper.
Welcome.
And this was paper 7 for the Slido questions. And with this presentation, we finalize all the presentations now, and we can start the Slido Q&A session, which we will take around 15 minutes. I'll now share my screen. And I will give each presenter chance to answer one question at a time so that we can take turns for each paper. So I'll start with paper 1. Just a second, let me share my screen. So all the presenters should be co-hosts, so you can unmute yourself. So I'll start with the paper 1 first question. Yes, Pradeep, would you like to answer this question?
Sure, I can. Can you zoom in a little bit? So
Of course.
Text
Just a second. Yeah, just a second. Let me zoom in here.
Or you can just switch to presenter mode.
Yeah, I think I
yeah,
resolved.
this is good. Yeah, I
Okay.
think this is good.
Yeah.
Okay, so I can take the first question. Why are you controlling the frame rate, not the quality? I've actually responded to the question, but the way the implementation actually works is that we're not controlling frame rate, we're observing frame rate, and we're affecting encoding parameters, which end up actually indirectly affecting the frame rate, which we continue to observe and continue to affect the encoding parameters. And that those encoding parameters that we are controlling, we try to control them such that quality is not negatively impacted. And I should also add that we do not control the resolution because we think it will actually complicate streaming quite a bit. So we try to keep the resolution the same and try to play with other parameters that both the encoders actually allow us to control.
Okay, now I'm going to ask Hadi, who asked the question. Hadi, does this answer your question or any comments further?
Just with dropping some frames, again, your quality of your video will decrease. So you are saying that you are saving the same quality, but with dropping some frames.
No, absolutely not. We're not dropping any frames. We cannot afford to drop any frames for live encoding at all. Right. So what we do is we affect the encoding parameters to change the quality at which a frame is encoded, not to drop the frame at all.
Okay. So the output of your encoder would be the decreased quality of the same resolution.
It depends on the incoming content. If the incoming content, the intent of the content adaptive encoder is actually to improve the quality, because by default, the configured settings for X264, X265 will achieve live frame rate at a given quality. And if the content is simpler, the quality will be bad. And the fundamental premise here is that when the content is simple to encode, we can improve the quality by adjusting the parameters. So when compared to straight line 264 or 265 encode for live encoding use case, our output will have better quality depending on the fluctuation of the content itself.
Thank you.
Okay. So let's go to the second paper first question. So the question is, task advice. Okay, I'm not going to read the questions, but I guess you can read them. Babak, I'm going to let you answer this question.
Supports different transport protocols. We are using HTTP transport. We basically using, testing HAS, which is based on HTTP. So the only transport protocol is HTTP, and is the QoE model supported? I'm not sure what does that mean, but we are using Bitmove Analytics dashboard, and there are a lot of metrics there, and we are not using any specific QoE models. how many players can be supported. Right now, we are running the test with three media players, but there is no limitation to the number of players that we can take into consideration when we run the test. So we can have as much as we want number of the players into the test.
Okay, Abdelhak, does that answer your question, or you have further comments?
Yeah, thank you, and thank you, Babak, for the explanation. Just one comment regarding the transport protocols. I mean the transport layer protocols like TCP Quick. If we have a permission to change those protocols and test our solution, so this is what I mean by the transport protocols. And the QE models, you know, in adaptive video streaming, we have a set of QE models like EN model or ITO model. So do you implement those models or not? So this just to clarify.
Yes, thank you, Abdelhak. The transport protocols, I understand what you mean now. We are using TCP only. So if you mean UDP that is not supported, because the network shaper that we are using is actually shaping the network on the TCP packets only. And then the QE models, no, unfortunately, we are not using any QE models here.
Okay, thank you.
Thank you. Let's move on to the third paper, the first question, again from Abdelhak. Ece, would you like to answer this question?
Hi, thank you. So, I mean, this is a question related to Dash.js mostly, and I would prefer our Dash.js maintainer, Daniel, to answer it. He is also in the chat.
Let me
So
check.
perhaps he can help better for this one.
Yeah, Daniel, I ask you to unmute so you can answer this question.
Sure, you should hear me now.
Yes, we can hear you.
So the question was, okay, yeah, this is something Dash.IF is actually working on right now. So they're defining some kind of resync representations, which we can use to switch between the qualities on chunk level. But this is not finalized yet. And as soon as it's finalized, we will also consider implementing this in Dash.js.
Okay. Abdelhak, does that answer your question? Maybe I didn't unmute you. Yes, now I unmuted you, so you can.
Yeah, thank you so much. Because I was just wondering if Daji is taking this feature into account. Basically, when the bandwidth drop, it's better to switch in the chunk level. But when we change the bitrate at the chunk level, I don't know how we can deal with the decoding issues at the site. So I'm just curious to know, is there any solution to avoid or omit these decoding issues?
Yeah, I mean, you need an IDR frame at chunk level in order to be able to switch on chunk level. And as I said, this is something which is pretty much implemented by this resync representation feature, but this is not completely done yet. So we need to wait for the spec to be finalized.
Yeah, okay, thank you.
All right. So let's move on to paper 4. The first question there from Hadi. And Tankut, would you like to answer this question?
Yeah, sure. Yeah, the regular, ABR streaming metrics are probably most relevant ones, the stream quality, number of stalls, which actually we collect using this metrics infrastructure that I've shown in the presentation. And one other thing probably is important when we talk about ad insertion is the delay before the ad starts playing. With the client side ad insertion, this is usually a problem because you switch to another stream source, you need additional buffering for that. And usually the player implements this by overlaying a second player on top of the mainstream player. So that switch between the content to to the advertisement is probably not a seamless experience. So by doing a server-side ad insertion, we can achieve this as well. So that's another important quality of experience metric, probably. The delay basically before the ad starts playing. So that's all that comes to my mind. And currently we don't take, other than the player's actions, of course, going through the regular adaptation mechanism, which we own the player. We own the player, as I mentioned, so we can do that. But maybe on the server side, since we manage every session, based on those metrics, we can probably take some actions as well. Currently, we don't do that, but maybe later we can do that as well.
Okay, Hadi, does it answer your question?
Yes, I was wondering about the delay that is made and that he responded to me. So thank you.
Okay.
Sure.
Very good. So let's move on to paper 5. I guess we will only be able to answer one question per paper today, but anyway, that's better than nothing. So I guess Reza, this is for you. Yeah.
Yeah. Okay. Today we handle this in the CMS by basic rules, by monitoring the CDN analytic. But for future, we are working implementing dynamic CDN switching by integrating client analytic. Yeah.
Does that answer your question, Abdullah?
Okay.
Or do you have further feedback?
Yeah. So is it Convivia Analytics or your customized analytics? And which metric that you are taking into account to switch?
Yeah, we consider normally quality QoE parameters such as delay in the client side, rebuffering, and also received video quality.
Ah, okay. Yeah. Okay. And the second part, are you using like an intelligent bandwidth allocation for each user at the edge, or
no? We do not use such a we don't use intelligent allocation bandwidth for user at edge.
Okay. Yeah. Thank you so much. Yeah.
Thank you.
Thank you. Let's go to paper 6. First question. Sarp, would you like to answer the question?
Can we set maximum load weight manually? Yes, clients can set the load weight manually, and if this is of course preferred way, another option is that the gateway assigns the load weight itself.
Okay, I can't seem to find Barish in the participants list. So I'm assuming that the question is answered, and I'll move on to the next paper. Okay. Next paper, Alper, would you like to answer the first question?
Yes. Yes, it can be used as markers because we store the markers on the database in our solution. Of course, other people who use the solution can store markers the place where they want, but it's totally specialized for the users, and it can be used as bookmarks.
Okay, I think Alp also is not among the participants right now, so I'm also assuming now the answer is given.
Okay.
Okay, and I guess we went through one round of question answers, Q&As. There are still a couple of questions for each paper, which is very nice, and I encourage as seen here, the presenters to reply and also maybe take offline discussions on the Slack channel if needed, and answer the other questions as well. It will be nice to have a reply to the questions that are asked for each paper here. And with this Q&A session, I think we finalized our our second session as well. So I would like to thank all the presenters for their hard work and presentations. And for most of you, of course, making the demonstration live would be more meaningful maybe. And next year, there's a chance that you can present your demonstrations live in Istanbul again in MMSys 21. So that's already, I guess, communicated also in the general channel in Slack. So I would like to thank you all and for your participation as well. And I would like to conclude this session, and we can go back to the usual agenda of MMSys again. Thank you so much. Have a nice rest of the day. Bye-bye.
Thank you. Have a nice time.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.